Hey, this is Matt from Speedscale. At my company, we were an early adopter of AI, and we've seen a lot of the trends that are happening right now in the industry early on. And I wanted to give you a set of reactions to the 2024 Google DORA report on software engineering trends, and give you some ideas on how we're coping with it and things that we've seen. I want to help you both interpret the results as well as back it up with some academic research to give you a bigger picture of what's happening. So without further ado, let's get started. Now, the DORA report itself is compiled by an organization that goes way back. It is now owned by Google, and it's a software engineering survey sent to many verticals, many software engineers all over the world. Now, in this report, they highlighted two main findings. I'm going to focus on one of them. The finding I want to focus on is that with a 25% increase in AI adoption, you can expect a roughly 7.5% increase in documentation quality and a 3.4% increase in code quality. Now, I'm going to take that at face value because that seems pretty intuitive to me, but I want to dive a little bit deeper on some of the trade-offs that you're getting with that and how you can sort of mitigate them. Now, in order to understand the trade-offs, I think it's helpful to look at the data a little bit more holistically. And fortunately, Jennifer Riggins over at the New Stack has given us a little bit of a head start on that by extracting some key metrics and interpretations. Now, the metric I want to focus on is the other things that change when you go over to AI. So you get the benefits we talked about. Some of them are meaningful, and some of them are kind of in the margin of error, 1.4%. I don't know what that means. The one I want to focus on, though, is the reduction in overall stability. So if you read this a slightly different way, what you'd say is, I get to produce documentation and slightly better quality code, but I get an almost commensurate drop in the stability of what I'm delivering. This doesn't seem like a great choice. It doesn't seem like a great trade-off, right? So early data is pretty mixed, according to these self-reported results. So let's go to more of the academic research around this to try to understand what's happening and why. So first, let's take a look at the positive assumptions made here. And for that, I'll dive into two academic papers. Now, they are put out by Google and Microsoft, who happen to sell these tools. And I never would assume that they would ever spend the results, certainly not for any particular reason. But I think we should take them at face value on this because they've been doing this a long time, and the results are pretty much in line with what I've seen, at least in my large customers and across our engineers. Google claims that about half the code that they produce, at least within this cohort, is generated by AI. It makes sense. They also claim large benefits from certain kinds of systems they've done, training systems to help engineers make better decisions. It's pretty advanced stuff. It's all good. I'll take this one at face value. So I think the benefits are real. The problem is they're not the whole story. Now, Microsoft has similar papers. I found many of these. All holds together reasonably well. But let's look at it a little bit from a larger context. Now, Carnegie Mellon put out a paper about a year ago that actually starts to nibble at what I think is really going on in this industry and why it's not everything it's cracked up to be. Now, you can read the Carnegie Mellon core research, and I encourage you to if you're interested. But they basically find there are 4 cohorts of people adopting AI. And what they basically found is that the people who just slapped AI on their code development got the least amount of benefit. However, organizations that actually rethought the problem from the ground up to use AI across the entire software development lifecycle got huge benefits. Okay, you can read more about that if you're interested. This is very intuitive to me because what I believe is happening is it's kind of like the early days of the internet. When the internet first came out, Craigslist was just a copy of classified ads. It's the same thing, but just in a different format. But as we get more sophisticated, learning this new paradigm of doing things, you get more sophisticated stuff like crowdsourcing reviews, doing AI, Gen AI summaries, doing better product search, all these crazy things that are made possible by the internet. You start to adopt all that, but it takes some years to do that. I think that's where we are with AI and software development. Specifically, I think what people have said is, I want humans assisted. I want a bionic arm, right, to make my humans go faster, right? That's fine, but it's only going to get you so far. What I believe is happening, and of course Carnegie Mellon researchers believe as well, is that what we're actually in the midst of is probably a decade long or more transition that will encompass the entire software development lifecycle. So what I'm saying is, you won't just use AI to create better code. You will use AI for various functions, and you will remove entire pieces of your process. So my company is focused on solving software validation problems and environmental problems. What that means is we don't write test scripts and move databases, do stuff like that around, right? That's kind of like the legacy way of doing that. What you do is you say, okay, this is going to be a somewhat non-deterministic system. And so we're going to have a somewhat non-deterministic way of validating it. We're going to have an AI test the AIs. Okay, so that's how we're solving it. And I think it draws upon a larger point that actually, I actually was told this by a physicist on YouTube, and I'll drop a link to her video, Sabine, who is, she sort of spotted this. So apparently physicists can see things that we can't, like quarks. But basically what she says is that software engineering is a deterministic outcome system. You are basically working a math problem when you're doing coding, which I think is intuitive to most of us. The problem with AI is it's based upon statistics and probability, which means that it is not necessarily deterministic. It's not there to give you the right answer. It's there to give you an answer. So it is going to take a long time for these systems to get better and better, right? It's not going to be an easy switch out, right? We're going to have lots of heuristics and rules, and we're going to be developing on this stuff for a long time to make it better. But my encouragement, if you want to get the most out of AI, is to actually think about the problem holistically and realize that AI is really pretty good at three things so far. Generating documentation and other human readable artifacts like certain kinds of code. It's good at summarizing bulk data because it understands patterns, and it's good at anomaly detection. So those are three really good things. However, if you want to go further than that and really get the benefits, you're going to have to start applying it elsewhere in your software development lifecycle. And I think we're just starting with that. So I encourage you to check out things like cursor.com, which they have a new kind of IDE. It's very helpful, and other tools. It's rapidly evolving, but don't think of it as a switch out replacement. Think of it as I've got to rethink this thing from the ground up and follow the leaders who are doing that. So anyway, I hope this was helpful. It's going to be a great decade developing this stuff, and I hope you enjoy the rest of your day. Thank you.